Greetings, my dear learners. This is C8404 Concrete Technology course. This is Module 1 of Unit 3. In first two units, you might have seen constituents of materials of concrete, and admixtures used in concrete. In this unit, we will be seeing how the constituent materials, how much proportionate each constituent material has to be mixed for making desired concrete. In this module, we will be seeing what are the principles of mixed proportioning, properties of concrete related to mixed design, physical properties of materials required for doing mixed design. So first, what is concrete mixed design? Concrete mixed design may be defined as the art of selecting suitable ingredients of concrete and determining their relative proportions with the object of producing concrete of certain minimum strength and durability as economically as possible. So in mixed design, first you have to choose the materials, and once you have selected the materials, you have to know the properties of the materials, namely cement, fine aggregate, coarse aggregate, admixtures, water. And once you choose the material, you have to proportion it such that when the concrete is done, it should have the desirable quantity. So this art of choosing the materials and knowing what proportionate each constituent material to be used is mixed design. So what are the basic principles of mixed proportioning? The purpose of concrete mixed design is to ensure the most optimum proportions of the constituent materials to fulfill the requirement of the structure being built. Mixed design should ensure following objectives: to achieve the desired workability in the plastic stage, to achieve the desired minimum strength in the hardened stage of concrete, to achieve the desired durability in the given environment conditions, to produce concrete as economically as possible, maximum water cement ratio or maximum cement content to give adequate durability for the particular site conditions, maximum cement content to avoid shrinkage cracking due to temperature cycle in mass concrete. So in the nutshell, there are three main properties of concrete. In its fresh state, it should have desirable workability so that it can be molded into any shape. Once it is hardened, it should have the sufficient strength to withstand the loads. Finally, it should have a sufficient durability so that the structure you are building with this concrete remains functional for a long duration. So as I told, the workability, strength and durability of concrete is important, and apart from this, the specifications where if there is some special type of building, you have to consider that also, and also the cost, the economic wise you have to consider. So all these 5 things should be in mind while designing the concrete mix. So first we will see one by one. So what is workability? The following points related to workability shall be kept in mind while designing concrete mixes. So what is workability? Workability is ability of the concrete to deform into any shape. So the consistency of concrete should no more than that necessary for placing, compacting and finishing. For concrete mixes required high consistency at the time of placing, the use of water reducing and set retarding admixtures should be used rather than the addition of more water. Wherever possible, the cohesiveness and finishability of concrete should be improved by increasing sand by aggregate ratio than by increasing the proportion of the fine particles in the sand. Strength and durability. The strength and durability require lower water cement ratio. You have to maintain as low as water cement ratio in the concrete. It is usually achieved not by increasing the cement content but by lowering the water at any given cement content. Water demand can be lowered by throughout control of the aggregate grading and by using water reducing admixtures. So the specifications means if, for example, if a building is exposed to harsh environment conditions like very severe extreme exposure conditions, so it should have a minimum cement content to meet the durability condition. It is given in IS 456-2000 reinforced concrete design. So the specifications are minimum compressive strength required, minimum water cement ratio, maximum cement content to avoid shrinkage cracks, maximum aggregate by cement ratio, maximum density of concrete in case of gravity gaps. So if the building you are constructing is in special area or it is exposed to very severe environmental conditions, you should have minimum cement content, etc., so that it satisfies all the requirements. So these must be in mind while designing the mix. Cost. The cost of concrete is made up of material cost, equipment cost and labor cost. The variation in the cost of materials arises from the fact that cement is several times costlier than aggregates. So it is natural in mix design to aim at as lean as mix as possible, means very less cement content. Therefore, all possible steps should be taken to reduce the cement content of concrete mixtures without sacrificing the desirable properties of concrete such as strength and durability. So what are the physical properties of materials like cement, fine aggregate, coarse aggregate, admixtures, water you required for doing the mix design? First you have to know what is the grade of concrete you are needed. Then type of cement, maximum nominal size of aggregate, grading of combined aggregate, maximum water to cement ratio, workability, durability, quality control. How much workability is needed? How long do you want the structure to withstand? What is the quality control you can achieve at this site? So these are the things, properties you have to know before you work out the mix design. First, grade of concrete. So the grade of concrete gives characteristic compressive strength of concrete. It is one of the important factors influencing the mix design. The grade M20 denotes characteristic compressive strength FCK of 20 Newton per mm square at 28 days after it is casted. Depending upon the degree of control available at site, the concrete mix is to be designed for a target mean compressive strength, applying suitable standard deviation. Since concrete is a heterogeneous material, you can't 100% say what you design you will get in this site. So you have to design for higher values so that the required strength is attained at the site. Type of cement. The rate of development of strength of concrete is influenced by the type of cement. The higher the strength of cement used in concrete, lesser will be the cement content. The use of 43 grade and 53 grade of cement gives saving in cement consumption as much as 15% and 25% respectively as compared to 33 grade of cement. So nominal size of aggregate. The maximum nominal size of coarse aggregate should not be more than 1/4 of minimum thickness of the member. It is found that larger the size of aggregate, smaller is the cement requirement for a particular water cement ratio. The workability of concrete increases with an increase in maximum size of aggregate, but the smaller size of aggregates provide larger surface area for bonding with the mortar matrix, which gives higher strength. Grading of combined aggregates. The relative proportions of the fine and coarse aggregate in a concrete mix is one of the important factors affecting the strength of concrete. For dense concrete, it is essential that the fine and coarse aggregate be well graded. Means you should have aggregates of all sizes in the particular range. In the case when the aggregate available from natural resources do not conform to the specified grading, the proportion of 2 or more aggregate become essential. Maximum water cement ratio. Abraham's water cement ratio states that for any given condition of test, the strength of a workability of concrete mix is dependent only on water cement ratio. So all the, for example, durability, strength, workability, all depends upon water cement ratio. Water cement ratio is the important parameter in the design mix and concrete making. The lower the water cement ratio, the greater is the compressive strength. Workability. Workability of fresh concrete determines the case with which a concrete mixture can be mixed, transported, placed, compacted and finished without harmful segregation and bleeding. It's the separation of coarse aggregates from fine aggregates and cement. Whereas bleeding is when there is excess water in the concrete mix, it tends to come to the top and remains there. It is called bleeding. Durability. Durability requires low water cement ratio. It is usually achieved not by increasing the cement content but by lowering the water demand at a given cement content. We have already seen. So if you want more workability and you need to maintain water cement ratio constant, you can go for adding super plasticizers, not adding water. And normally the procedure is if you want more workability, normally the person will add more water. But for a good concrete mix and for good desirable concrete, you have to maintain the same water content. You can reduce the water required by adding plasticizers or super plasticizers. Water demand can be lowered by thorough control of the aggregate grading and by using water reducing admixtures like plasticizers and super plasticizers. So with all this, you also need the specific gravity of cement, specific gravity of fine and coarse aggregates, water absorption capacity of aggregates. So you have to do this material testing and get these values like specific gravity and water absorption capacity of various constituent materials before working out the mix design. Quality control. Concrete, like most other construction processes, have certain amount of variability both in materials as well as in constructional methods. This results in variation of strength from batch to batch and also within the batch. So the mix design is done with the aim of having desirable workability in fresh concrete, and once it is hardened to have sufficient strength, and finally the durability. So these three are the main characteristics or importance required to be considered while doing the mix design. So one should consider all these three things and also specifications, cost while doing the mix design of concrete. In the next module, we will see what are the step-by-step procedure in doing the mix design as per the latest IS 10262 2019 code. Thank you.